In example 6, we're asked to determine if the two expressions are equivalent without solving, and then explain why or why not. This problem is a little bit tricky if you either don't know the distributive property or don't have a good understanding of what happens when you have the opposite of an expression that has two terms in it. What's going to happen in this case is we need to take the opposite of this expression, and we're going to need to take the opposite of each one of these terms. So the left side is negative 3a, that's the opposite of 3a, and then the opposite of 2 is negative 2. So that one little step in there, if you didn't know to do that, I hope you can take a look at this right now, and I hope you can see some things that are going on with this equation. We need to figure out if they're equivalent, which means that, let's see, is this expression, does it have the same value as this one? Is this equal sign okay here? We have a 14 and a 14. We have a negative 3a. We have a negative 3a. And then we have a negative 2 and a negative 2. Turns out that each side is exactly the same. So we can say, without a doubt, that the left expression is equivalent or equal to the right expression. So I think I'm going to write, let's see, determine if the two expressions are equivalent. They are equivalent. And my reason here says explain why or why not. So they are equivalent because, this is a good word to use, after you simplify the left by one step. You could simplify this a little further, but we're just going to say by one step here. Okay, they are equivalent because after you simplify the left by one step, the left and right side of the equation, and those are equal. So the left and right side of the equation, those are equal. I like to reread my sentences. This might not make sense English-wise. Let's see. So they are equivalent because after you simplify the left by one step, the left and the right side of the equation are equal. Yep, that one I think is good.